From the dawn of history, man has dreamed and planned of ways to get away from his earth-bound existence, to travel among the stars. Now, for the first time, the way is open. We know how to travel to the moon and beyond, and in a short time, we will, using our largest and most advanced space rocket, the Saturn super rocket.
With the successful firing of the Saturn, a gigantic stride has been taken in the exploration of space. Many times I've been asked why we are exploring beyond our Earth. I will give you a few of the many valid reasons. First of all, of course, is knowledge of the Earth, our solar system, and the universe. Throughout history, new knowledge has always improved the lot of the human race. From the tangible, practical standpoint, mankind will receive enormous economic benefits from the conquest of space. One important objective is to establish weather satellites to ease the enormous cost to society in lives, suffering, and property damage caused by storms and hurricanes. Communication satellites can provide reliable television, radio, and telephone service to any point on Earth and produce a revenue to the nation. A navigation satellite will make transportation by ship and aircraft safer and faster. Achievement of our major goal of landing a man on the moon and returning him safely to Earth within this decade will be of inestimable value. We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability.
Approval was given in November 1958 to start construction of the first stage of this space booster, the largest rocket under development in the United States. A team of scientists and technicians under the leadership of Dr. Werner von Braun planned the system. How to assemble, test, transport, service, fuel, and erect the spaceship carrier. The unique rocket development facilities of the Marshall Space Flight Center at Huntsville, Alabama, were altered for the task ahead. In time, fabrication started at the center. Tanks were formed from huge sheets of metal. Jigs and fixtures were developed for construction and assembly. Special procedures were used to assure proper alignment of the propellant tanks and powerful engines and other complicated parts, so they would perform properly and would withstand the almost unprecedented forces they would encounter. At the same time, work was progressing on the complicated guidance needed to direct and control this monster. Delicate gyroscopes and elaborate electrical equipment were miniaturized and tested to see if they would perform the difficult job required. Thousands of mathematical problems associated with rocketry and space travel had to be solved before final testing. A search for materials and structures to withstand the rigorous abuse of space flight was conducted successfully. The rocket development would call for the use of special metals and structural materials. Blueprints and plans were produced in quantities that would stagger the imagination. Nothing could be left to chance. Exact specifications were required for production of the complicated parts, down to the smallest nuts and bolts. Aeroballistic research, including wind tunnel tests, continued throughout the development. Precise studies had to be made to determine the type of upper stages to be added to the powerful first booster. By the spring of 1961, the first stage of the first flight booster was assembled and ready for a captive firing. It was moved the short distance to the test area by road and placed in a specially constructed static test tower for a captive firing. Giant clamps would hold the rocket in place during this vital test. All 8 powerful engines ignited to prove that the preliminary planning and toil were worthwhile. The first and later tests were completely successful. While work was progressing on the rocket first stage, contractor plants in other locations were working on the upper stages, which would be added to make a complete space transportation vehicle. The same care and precision was used for this work. With the booster now ready for an actual test, it was rechecked and moved to another area to be prepared for shipment to Cape Canaveral. Here, it incidentally passed another Saturn being moved to the static test area. Exactly on schedule, as previously planned, the giant rocket was started on its journey to the firing site to meet its date with destiny. Enclosed in its enormous barge, it started its long trip to the coast of Florida. A few months before the boat trip started, trouble struck in the shape of a rupture of a Tennessee River dam, causing feverish planning and work to enable this rocket to meet its scheduled firing. The barge could not get below the dam to continue its trip. It was necessary to unload the heavy rocket, transport it around the dam on a newly constructed road, and reload it on another barge. With this crisis solved, the new barge continued down the river with its valuable cargo. The roundabout route followed inland rivers for the 2,200-mile trip down the Tennessee and Ohio, down the Mississippi to the Gulf, and then to Cape Canaveral. At the previously constructed launching site, plans had been made to receive the space traveler. The special transportation equipment and the protective weatherproofing cover were removed. The ponderous giant was lifted to its last resting place on Earth. Huge cranes delicately raised the rocket and placed it within the enfolding arms of the service structure. For the first experimental test flight, dummy upper stages were added. Later firings would use live upper stages for the Earth orbiting and other space missions. The Launch Control Center, a blockhouse with walls 12 feet thick, was instrumented to monitor and handle the complicated firing procedure required to start the rocket on its way. Ton after ton of liquid oxygen and fuel were added to the rocket. For this first test, the booster carried 600,000 pounds of propellant. The upper stages were weighted with water for this firing. Last-minute checks were made of the complete system. Everything must operate correctly in this initial test of the rocket on which the United States and the whole free world is depending to give a giant step toward manned exploration of space. The countdown started 10 hours before the firing time. Now, the time grew short. People throughout the world were entranced as they stayed glued to their television and radios and read the newspapers. Tension mounted in the blockhouse. A successful firing would show that the Saturn was on schedule. A failure would mean months of corrective work. Five, 4, 3, 2, 1. Ignition. Second by second, hope grew that everything would go as planned. While this first firing was planned for a trip of only 225 miles down the Atlantic missile range, later firings with live upper stages would give the space rocket orbital capabilities. The guidance program was obviously working as planned. The tilt program began 10 seconds after liftoff. The rocket reached an altitude of 90 miles on this trip. As the Saturn continued on its path, the scientists and technicians knew that their dreams had not been in vain. Rocket technology had been extended by a considerable margin. They could envision the later, more powerful versions of Saturn that would take men on the first trips around the moon. It was now definitely only a matter of time until man would first set foot on the moon. Until he would unravel the mysteries of Mars. Until the void of space becomes the highways of the future.